Hello, here's a couple application examples to check out. So the first one, these are two situations where quadratic equations come up in application problems, which is going to happen a lot. So this one is about a rectangular computer monitor, where the size of a rectangular computer monitor is the length of its diagonal. So from one corner of the screen over here to the other corner of the screen over here is the definition of the size. So when we say a 15-inch monitor, that means the size of that diagonal. And if it says the length is supposed to be 3 inches greater than the width, let's try to draw a picture of that. So we just know that when we say a 15-inch monitor, that's the length of its diagonal. And so this is going to be 15 inches here. And then there's also the width and the length here. So you can make up a variable for either the length or the width. I'm just going to say W is the width, measured in inches, and there's that. So then if it says the length is 3 inches greater than the width, this is going to look like W plus 3 here. And we want to know what are these dimensions. The dimensions means find the length and find the width. So to do that, we can use the Pythagorean theorem, which says that if you take one leg and square it, that would be W squared, plus the other leg and square that, you'll get the same thing as the square of the hypotenuse, the side opposite that right triangle there. So that gives you an equation you can solve. This one doesn't look like you can solve it with just extraction of roots, because remember, if you just take the square root of this whole thing, you can't just cancel that out with the squares inside of it when they're separated by the plus. So we're going to have to solve this by factoring. So we'll do the W plus 3 times W plus 3 squared here. So we'll have to FOIL this all out. And we'll get that W squared from here, plus this W times this W is W squared, plus 3W plus 3W plus 9 is equal to 225. And we can combine some like terms. The W squared plus W squared is 2W squared. The 3W plus 3W is plus 6W. Plus 9 is 225. So we'll subtract that from both sides, which gives you this. And this is a pretty mean one to factor. We're going to need to have a 2W plus something and a W plus something over here, because those are the parts that we need to multiply to get 2W squared. These two things here need to be able to multiply to get negative 216. And then also when we FOIL everything out, we need to make sure we get a 6W there. So this will take a little bit of work. I recommend writing out some factors of negative 216 to help, because we're going to need some of those factors here. You might start with something like 54 and 4, but then if you try them, you're going to realize that those are kind of too far apart. If you FOIL them, you're not going to get something small like 6W. You're going to get something in like the 40s or something. So maybe some numbers that are closer together. Negative 27 times 8 isn't a bad guess, but if you plug it in, you see that's not going to work either. There's another one. By the way, to get these factors of negative 216, I didn't show you how I'm doing it, but I'm just taking my calculator and just doing 216 to find some numbers, because if 216 divided by 9 is 24, that means that 9 times 24 is 216. So that's just my way of getting some factors. So now I've got negative 24 and 9. Let's see what happens if you try that. Let's try a negative 9 here and a 24 here. And you're going to get 24W and then, oh, negative 18W. And sometimes this is going to be like the 10th thing you try. And that's okay. You'll get some practice. There are some methods to factor things like this that will make it quicker, but then you have to learn the method too. So anyways, I got it to work, so now we can say 2W plus 24 equals 0, and W minus 9 should equal 0. Those should both give you solutions. So if you subtract the 24 from both sides, you'll get 2W equals 24, divide both sides by 2. So, sorry, I just skipped ahead a little bit because I had to fix a mistake. And anyways, these are the two solutions of this that we get from the two parts here. Those are a little close together. So now I want to point out that we do get two solutions, negative 12 and 9. These are, if you check it, you'll see that these are actually both solutions of the original equation. If you plug in negative 12 into W here, it is going to work with the equation. However, that doesn't mean it's an answer to the question, because that couldn't be an actual length of a computer screen. You've never seen anybody advertise, oh, look at this negative 12-inch monitor, because that would be even smaller than a 0-inch monitor, and that's no good. So we're going to use the positive result and take that and see what are the dimensions. W was the width, so we still need to find the length, but it says the length is 3 inches greater than its width, so we can now just say that an answer and the screen is 9 inches by 12 inches. So that was a tricky one. This next one is tricky too. Francine is designing the layout for a botanical garden. It's got a square herb garden here with a path 5 feet wide through the center of the garden, and to include all the species of herbs, the planted area, the dark blue stuff here, that must be 300 square feet. So let's find the dimensions of the herb garden, which would just be the length of a side here. So the dimensions are, if it's a square, the dimensions are just going to be the same. So we can just say that x is the length of the side. So this is x, and then this total distance here is x as well. We also know that this distance here is 5, because she wants a 5 feet wide path there. And we've included a lot of the information that was given here, but we haven't used the number 300 yet. What does that have to do with that? That's the area of the blue part. So if we can get an expression for the area of the blue part to be equal to 300 square feet, that would be an equation we can solve. The trickiest thing is getting an expression for this planted area in terms of x. So the thing I noticed about it is it's two rectangles, and as you know, the area of a rectangle is equal to its length times its width. And to get the length of the rectangle, we can just say that's x. but what is the width of this rectangle? And it seems a little weird that I'm saying this rectangle because there's really two rectangles. But what you can imagine is, you're going to have to imagine it because of the magic of computers. If you take that and just move it over, oh, that didn't work right. Well, okay, pretend that you could just keep the area the same, but just slide this over here. There, that's what I meant to do. So just pretend the path is along the side, and it's still the same area. I just moved the one planted area to the middle. So that way we can see it, imagine that it's all one rectangle, and it works out the same way. And that way you can see what is the length of this side. The length of that side is going to be x minus 5, because this is 5 feet from here to here, so this must be x minus 5 left over, because the whole width is x, but we're not including the 5 that makes up the path. So this is just going to be x times x minus 5, and we can distribute the x into there, get x squared minus 5x equals 300. Subtract the 300 from both sides, and that leaves you with 0. Now that you got 0 on one side, you can solve this by factoring. So we need two numbers here. We can multiply to get negative 300 and add up to negative 5. So you have to try some factors of 300. This is the one that works after some trial and error, and that means that either x minus 20 is 0 or x plus 15 is 0. If you solve this by adding 20 to both sides, you'll get x is 20 or x is negative 15. And in this case, the negative 15 doesn't make sense, but the 20 does, because you can't have a negative length for the side of the garden. So the dimensions of the herb garden are just going to be 20 feet by 20 feet. Alright, that was a long video. Thank you for your patience. Thanks for sticking with these problems. These are some of the trickier problems in the book. So stick with it. It's going to be tough. The next item is going to be to read a bit of the textbook. Reading a textbook is tricky. You probably aren't used to reading math textbooks so much, but hopefully over the course of the semester you develop that as a skill a little bit, because it is a really important thing to know how to do in future math classes. Alright, and I'll see you in class.